Yes, but this will be our last section. Now, I will have to say, this may be the easiest section in the book at this point. No, I think you'll find this to be the easiest. All right, we're going to go back to limits. Everything circles around. We started with limits. We're going to end with limits.
I didn't like limits.
So, we're going to go, and at the end of this slide, we're going to go through a little lesson, then we're going to go through and do these 4 problems involving limits. Okay, so we'll come back to that at the end, so you don't have to tell them now. But, first we need to know, do you guys know an intermediate, interdeterminate form of the hospice rule? Who knows how to pronounce that correctly? With the accents. Those hospice rules, is that anything? Well, you know what? When you guys do your project at the end of the year, you could figure out the correct pronunciation of that. All right. So first of all, we're going to recognize limits that produce, all right, indeterminate forms. And we're going to apply L'Hopital's, I think it's the correct name, but I don't want to be quoted on it. Hospital. All right. To evaluate these limits. So first of all, indeterminate forms. We need to know what those are. When we looked at limits, okay, we got stuff where, for example, if you look at this, if you put -1 in, you got 0 on top, 0 on the bottom. Okay, 0 divided by 0 does not exist. There's other things where you can say, all right, let's find the limit as x goes to infinity, and you get infinity on top and infinity on the bottom. Okay, but we had methods of finding these limits. The method we used here, okay, was we divided the top and bottom by x plus 1. So we canceled that out, and then we had this left. We could put -1 in, we could find this limit. Okay, the method we had with this is we took and we divided the numerator and the denominator by x squared, so we ended up getting 3/2. So we had methods to finding those limits. Well, today we're going to learn a different method. Okay, and this new method only works for finding limits when you come into these situations. When you end up getting 0 divided by 0 or infinity divided by infinity. Okay, that's when you come to this rule. Here's another example. E to the 2x minus 1 divided by e to the x minus 1. If you can remember when we dealt with this, we multiplied by the conjugate. You guys remember multiplying by the, actually this isn't conjugate, this is factored. Because I don't know if you realize it, but this is the same as e to the x squared, because you take exponent times exponents. Okay, so we can factor this out. We can cancel out e to the x minus 1 on top and bottom, and you'll get 2. So here's another example of what we did with limits. Bring back good memories. Now, what about this one? E to the 2x minus 1. Okay. If you look at this, we want to find the limit as x goes to 0. If I do that, I get 0 on top and 0 on the bottom. So some of you may, this is probably the thoughts, a lot of you probably say, well, let's split this up, right? Well, what's e to the 2x divided by x? Does that tell us anything? No. Okay, so we can't always use those methods we learned. We came up with this new method. Now, if I asked you to find that limit, and you can see the equation in blue, if you graphed it, okay, we want to find the limit as x goes to 0. Here's what it looks like on the graph. You can sort of see it's 2. And then we can make a chart of values. We can make our chart and see as x gets closer and closer to 0, you can see this is getting closer and closer to 2. So we sort of know what that limit is, but what it would be a way of doing this if we couldn't graph it, if we couldn't, didn't make the charts. And that's where this rule comes in. So before we get to this rule, okay, first part is we need to recognize when we can use this rule. Okay, when you put that value in, you get 0 over 0 or infinity over infinity. And then you go to this rule. So here's what the rule basically says. If, okay, you have these values, such as this, okay, as the limit approaches this value, you could say then that f of x divided by g of x, the same limit would be the derivative of f of x divided by the derivative of g of x. So we can sort of use this process now. And the reason why I say this may be one of the basic or easier ones, we know how to find derivatives, don't we? Yeah. All you do is take the derivative of the top, derivative of the bottom. There you go. Alright, so that is, now, the extended mean value theorem can be used to prove this. This is not in your packet. And you can actually do the proof with the extended mean value theorem, which you did earlier. And we talked about that C value between A and B that would give you that. Okay, so that's really the proof behind it. And we can get more into the proof later, but this is basically your hospice rule. Okay, and just realize, this only applies, okay, as you approach this value C, when you get one of these things, you'll either get infinity over infinity, or it could even be negative infinity over infinity, or infinity over negative infinity. Okay, any one of those ways, or 0 over 0. Okay, so that's the very first thing, if you get this on the AP test, is you want to put those values in for x and see what you get. Do you get infinity over infinity? Do you get 0 divided by 0? If you do, then you say, oh, I can use this rule to find its limit. All right, so let's take a look at this problem now and find the limit as x goes to 0. And this is the first thing you'll do. If I put 0 into the top, what do I get? What's e?
1.
Oops. You get 0, don't you? Yeah, because you get 1 minus 1. And then the bottom you get 0. So, right? So when I do direct substitution, not going to work. So that's where I now take the derivative of the top and the derivative of the bottom. So go ahead and do it. Now remember, we already looked at the graph, and we should have an idea of what it's going to be. I just hope you guys don't have any issues finding these derivatives for this whole year. All right, so on the top, don't forget to use the chain rule. So it should be 2 times e to the 2x. On the bottom, derivative of x is just 1. So now, I have its derivative. Can I put 0 into this? Yeah, because it doesn't make, yeah, when you put 0 in, you end up with, did you?
Accidentally, yeah.
Don't make it more complicated. So that's hospice rule. Really not bad, is it? I wish you had more. Now just remember when you can use it. Alright, so you may come across these things. Okay, but you can only use this rule if when you put in, you get 0, 0, or anything over here. So here's an example that people would want to use hospice rule. E to the x divided by x. If you put 0 in, what's e to the 0 power?
1.
1. So you get 1 over 0. Is 1 over 0 one of the ways? No. So do not do this. That would be incorrect use because you can't do it in this case. So now that we have that down, I have these 4 examples I want to do. So, first example. If I put 3 in, I get a 0 in the denominator, so I can't just do direct substitution by its limit. So let's go ahead and find the derivative of the top and derivative of the bottom. So the derivative of the top is 4x minus 1, and the derivative of the bottom is 1. So if I put 3 in now, I get 4 times 3 minus 1 over 1. And that is going to give me 11. Let's just pick it up. Now, by the way, if I use the other method, what's the method that we learned how to do this before? Factor the top, factor the bottom. So what's the top factor to be? 2x plus 5? Okay. And you can sort of see then, this is the method we used earlier. Okay. And if I put 3 in, I get 6 plus 5, which is 11. So you sort of see we end up getting the same answer. Sine of x over x. Remember we did that earlier in the year? And we said this is one that you need to know, and it was 1. Was it?
Yeah, we got it wrong. So we have. Those Joe's fault. Yeah, thanks. They said it funny. we got confused.
When was this last one?
Is that why you lost the last?
Yeah, we lost the last.
Wow.
By one question?
No, they almost doubled us. They were.
Well, this could have.
No.
This could have made you or break you. Maybe you should give up after this.
Well, now you know another method of doing it. So what's the derivative of sine of x? It's derivative of x. 1. So now what's the cosine of 0? Now you know another method. What?
The exact particle for one.
You know what he's saying? Can you interpret?
I mean, I would just write cosine x. I would never write the over one, so exact work.
Oh. No, you gotta show it. Oh, tough one. What's the derivative? We have a hard time with this one. What's the derivative of ln of x?
Over x. Morrison, why'd you say that?
It's always the integration of ln of x, you guys. So then the derivative of x is just 1. So here's what it ends up being. Okay. Now, what's the limit as x goes to infinity? Be careful because some of you guys on the AP test will do this. Does 1 over x equal 0? No. The limit as x goes to infinity of 1 over x equals 0. If you put this work on your AP test, you'll lose points. So make sure you use proper things. So don't say something like this. By the way, that's where we're going to spend the final couple weeks is talking about how to write things properly. Make sure you don't make mistakes. All right, last one.
Over x. 1 over x over x.
I want to find the limit now as x goes to negative infinity. Now, if I put negative infinity squared at the top, that's going to go to what? The top's going to go to
Positive.
positive infinity. What's the bottom going to go to?
Positive.
Positive. So I end up with infinity over infinity. So I probably should have done it first to show you that, hey, this is 0 over 0. This ends up being 0 over 0. This ends up being infinity over infinity. So that's how I know I can use it. And that's really the first step. Okay. And I should have put those. So in this case here, I get infinity over infinity. So when I take the derivative of the top, I get 2x. Derivative of the bottom would be negative e to the x.
Negative.
Yes, negative stays there. I want to find the limit as x goes to infinity. So now, if I put infinity, doesn't the top go to infinity and the bottom go to infinity still? Yeah. So I get negative infinity over infinity, which is fine. No. I'm going to say no then. One might be twice as big as the other. One might be. So now, what I want to do is I want to do this again. Just like we did last year, sometimes you got to do it twice. So now I take the derivative of the top, which is 2. And the derivative of the bottom would now be negative x. So now I can actually find the limit as x goes to negative infinity. And you can sort of see as x goes to negative infinity, what is this going to be?
0.
Be 0. Okay, so it's not 1. Alright. That's the rule. Pretty easy, isn't it? Wow. You guys took a quiz. We got through the lesson. It's almost like the clock's frozen. You didn't see me move. You guys been.
Fine.
So you have time to get your homework completed before you leave today.